Hello viewers, my name is Damilare. In this lesson, we'll be looking at the topic alloys. Alloys. What is the meaning of alloys? To start with, pure metals are not used widely because many of their properties, such as hardness, tensile strength, resistance to corrosion, and luster, can be improved by mixing them with other elements. When you pick up some metals, you see that they are not as hard as you desire. Their strengths, they cannot bear tension. They can easily corrode. They can easily rust. They may not shine the way you want. And that's why the knowledge or the idea of alloys come in, whereby you combine the metals together to get your alloy so that it can give you all these required characteristics, just like hybrid in agriculture. Maybe you have banana and it's not giving you what you want, like the size you want, the taste you want, so you can crossbreed it. When you crossbreed it, you'll be able to give you your desired goal. So the same thing applies to metal, so that when you mix the metals together, it gives you alloy so that it can become harder, more tensile strength in it. It can resist corrosion and become lustrous, and then you can have your desired goals. So this is now the full definition of alloy. So an alloy is a substance prepared. It means they always prepare it by adding one or more elements. So they always add an element. It may be one, it may be two. You add it to the base or the parent metal. The parent metal is the actual metal you are using, but what you add to it is just extra elements so that you can obtain your desirable products. So and most times the element they always add is always metal, or you add carbon. So your desired metal, you add carbon to it or another metal so that it can give you what you expect. Now, a true alloy can be considered as a uniform mixture. That means there should be a particular amount of metal you will add, a particular amount of carbon you want, so that it can become a true alloy. It is usually made by melting the components together. So you take maybe iron, you melt it together with maybe steel. So by the time you melt them together, it becomes alloy. Maybe the copper and zinc, melt both of them together, so that they can have a uniform mixture. That's a true alloy. And again, it can solidify your mixture. Then the components must be soluble. That's another thing. They must be soluble in each other, meaning that the copper must be soluble in the zinc if you want to do brass. So they must be soluble in each. That means they should blend. That's just the mean, they should blend. So when molten, they should be soluble. When you melt both of them, they should dissolve and they should mix with each other and should not separate, because it's just like you molding cement and sands together. So you should be able to blend so that you can use it to hold your wall. So that is just the same way. It should be soluble in the molten state. They should not be separate. They should not be in distinct layers when the mixture solidifies. So they should blend together. They should not undergo any chemical changes during the process of alloying. That means where you have mixed them together, one should not be trying to behave somehow while the other one behaving in another way. No. Chemical reaction or chemical changes should not start taking place. They should agree together. And the percentage composition of the component element in an alloy, it may vary according to the desired qualities. That means it depends on the strength you are expecting. That will determine the ratio of maybe copper, ratio of zinc. That will determine the brass you will form. Maybe you want it to be very strong, so you can determine the percentage yourself. Sometimes the metals in an alloy mixture are only partially soluble, e.g. in certain types of brass, so they may not be fully soluble partially. And in some alloys, the metals combine to form intermetallic compounds. So they can be between metals. For example, in an aluminium copper alloy, that means you are adding aluminium with copper. So some of the copper will combine with the aluminium, while the rest, they will form a solid solution with it. And looking at alloys, they are economically important, since most of the things we use are made of alloys rather than pure metal, so they are economically important. They are using them for many things. So these are some alloys here. We have brass. So in terms of percentage, you can take 60 to 80% of copper, then 20 to 40% of zinc. So, and this makes it stronger and more malleable. That means so that you can hammer it the more than ordinary copper. Then greater workability, so that you can do a great work because of lower melting points and more attractive appearance. So when you join copper and zinc, the appearance will be more attractive. So, and it will not corrode easily. So what will you now use the brass for? You can use it to make moving parts, like moving parts of machines like your watches, your nuts, your bolts, your rod, musical instruments, your ornaments. So it will help you to do many things, since it has given your desired expectation in terms of appearance and then prevention of corrosion and great workability. Then let's look at bronze. Bronze needs enough copper, like 90% copper and just 10% tin. So this one will make it become stronger than ordinary copper, and it will be able to resist more chemical resistance to chemical attack. So chemical will not easily attack it because you have already blend them together, and they will be more attractive in appearance. So most times they use this one for coins. So bronze, they use it for coins, for medal, for sculpture, for general metalwares. Then another alloy is duralumin. From duralumin, even from the alumin, mean that there's aluminium there. The U, you can use it to remember copper. The Du, just like Cu, to remember copper. The M from the min, use it to remember manganese. That same M again for magnesium. So the highest should be aluminium, highest 95, followed by copper, little copper, then the main ones will be the same, 1 magnesium, manganese. So these ones, they will become very light, yet they will be stronger than ordinary aluminium. So you can use it to construct your aircraft, your ships, your cars, your machineries. Then another thing is steel. What do they combine to give you steel? So that's iron and carbon. Iron and carbon that make up steel. So you can say maybe FC, the S, steel, FC, maybe like football club. So meaning that there is enough iron. The carbon should be very low. So this one will become more malleable. That means you'll be able to hammer it, and it will be ductile, draw it to iron, to wire. So ductile even more than iron. It will be harder and stronger. It will be able to withstand stress. So because of that little carbon, so because impurities make steel stronger. So you'll be able to use it to construct your bridge, your ship, your car, your machinery. Then we have stainless steel. So this one also has enough iron, 60 to 80%, chromium, nickel, they are all there. So this makes it more hard, resistant to corrosion. It will not corrode easily. It will make it attractive in appearance. So you can use it to make cutlery, tools, and surgical instruments. So we also have what we call permalloy. Permalloy, that's iron and nickel. So this one is strongly magnetized. So all these ones are majorly for magnetism. That's permalloy alnico. So the permalloy is iron and nickel. The alnico, iron, aluminum, nickel, cobalt, soft solder, lead, tin, and antimony. So all these ones so that there will be low melting point and high tensile strength. So they use it for welding and plumbing, for printing. So that's just a summary of what we have in alloy. So thanks for listening.